Hey everyone, and welcome to our next live session on this mini series on machine learning and artificial intelligence. In today's episode of this mini series, we're going to take a look at programming languages for machine learning. As always, this is your technical trainer here, Shashank, with this particular video where we're going to take a look at what are the popular programming languages available for machine learning, which one should you use, which is the better option. We're going to answer all of these questions. As always, since it's a live session that we have conducted for you guys, if you have any queries in between, you can feel free to ask us. And just to point out, there are 4 videos in prior that we already have. You guys can go through those who are watching this video for the first time. There are 4 videos in prior to this in this mini series where we have learned about what exactly is artificial intelligence, machine learning, deep learning, and transfer learning in detail, or at least in brief. From here, let's go ahead and take a look at what are the programming languages that are there for machine learning and which one are we supposed to use if we are developers or if we are beginning to make a career. What should be the right option? So let's begin without any delay. So first option that always comes to everyone's mind when you want to learn machine learning is Python. Everybody thinks of this. This is the most popular language to learn or to work on machine learning. So what makes Python so popular? What makes people choose Python? Here are the reasons. Python is basically the most popular programming language in order to work on machine learning. 70%, almost 70% of machine learning engineers work based on Python alone. That makes it nearly 9 million developers worldwide are working in Python. That means over 9 million developers. That's a huge community of developers. You can always seek out and take help from this community. You can always seek out and take help from others. You can always seek out for some packages that or some modules that other developers in the community have developed and access it. Because as we know, we are freely allowed to develop our own modules and release them within Python. That's the main advantage when it comes down to Python within this. Followed by Python. Now, if is this the only reason? Like just because more developers are using it, does that make it the best option? Not exactly. The reason more developers are using it are because it's the best option. So the main reason for Python is because it's platform independent, so that if you create any Python program in your computer, it can also be used in any other computer elsewhere as well without any problem. So this compiled or interpreted versions of programs can easily be taken up to any other system and can be used. There's a lot of advantages. So Python can literally be used in any system. Another advantage, it's very easy to learn and read. It's one of the easiest programming language to learn. There's a reason why Python is there in 8th grade syllabus right now. Even in 8th grade, as young as 8th standard, kids are learning Python nowadays. It's that easy to learn and understand. And the other advantage is tons of packages are available. Even Google themselves release their own packages in Python itself. So when Google themselves release their own packages in Python programming language, which you can use later on, it makes it a very useful programming language. Because as we learned in our last session, we took a look at something called transfer learning. In transfer learning, we looked at a couple of algorithms, like there is an algorithm called BERT and so on. All these are implemented in Python by certain companies alone, and you can use these algorithms directly without spending too much time to create your own code, develop your own code, or so on. So these are the big advantages that you can have within this. Let's move ahead from this. So now we have a clear idea as to why people prefer Python. It's easy to read and understand, and lots of packages are available. So when we talk about machine learning, there's one thing which I haven't explained in detail in our prior sessions. That is, if you want to become a really good machine learning developer, machine learning engineer, the first thing you need to do is to be able to read data. When I say read data, a lot of companies give you data in different ways. So think of this. Let me just clear the canvas. Think of this. Let's say you're reading data of COVID from certain state of a country to perform some machine learning analysis, or let's say you're reading from stock market data or whatever it could be. Now, different companies or different governments may give you data in different formats. One may give you in Excel format, one may give you in a database format, one may give you in, let's say, a PDF format, and so on. So all these formats you should be able to import into your machine learning language, whatever programming language is there. You should be able to import these formats. So for importing, you need certain packages. Certain people have already developed it. When you have imported these packages, since they will take a large size, since they will take huge amount of size, they should be stored in memory efficient way. To store them in memory efficient way, you need other packages that are also already created for Python. And then you need to perform machine learning on top of them. To perform machine learning on top of them to predict something, you need certain packages as well. Those are also already created by many developers and are already available in the world for Python. And when you get the results, you're supposed to show the result to the user or result to the stakeholder or the client. Now think of this. The client wants to know how COVID will go in the next 2 or 3 months. If the client wants to know that, you cannot give a client an Excel file where there are two columns. One column is called date, the other column is called COVID cases, and you cannot give the client this 2 month Excel data and ask the client to understand it. Client will be like, your job is to explain to me in a very graphical way. I cannot go through thousands and thousands of rows. I cannot go through so much amount of data to understand. So in that case, you need packages to visualize data. You need packages to particularly visualize data so that people can read it and understand it effectively. So a person who only works on machine learning is called a data scientist mainly. Of course, data scientist also needs to know how to read the data from different formats to work on it, whereas a data analyst generally uses this part to analyze data. So you need a particular package to read these formats and to analyze them and to visualize them as well. So whether you're a data scientist or whether you're a data analyst, whether you want to work in the field of data scientist, data science or data analysis, you need to know all these together. Regardless, you need to know how to read multiple forms of data. You need to know how to make it memory efficient. You need to know which packages are used to implement machine learning algorithms, and you need to know how to visualize results in a graphical way, whether a stock market value will go up in the future, low in the future, or COVID cases are going to go up or low. To figure out all of these, you need graphical views. So all of these are equally important. So whichever programming language you're supposed to choose, if you're having all of these together, that gives you a huge advantage. That's exactly what Python does. Python, you're able to read different formats, store in a memory efficient format, obtain machine learning algorithms using certain methods, and visualize them as well. Everything you're able to do in Python. That is what makes it a very easily choosable option for machine learning engineers. Followed by Python, there's one more programming language that is often used. That's called R. R programming language is often used by statisticians. It's a programming language that is created by statisticians and created for statisticians as well. So this particular programming language has more than 2 million developers worldwide. It has a very active community. Of course, it's not as active as Python with over 9 million developers worldwide. It still has a very active community with over 2 million developers worldwide. And there's a tens and tens of thousands of packages available for statistical analysis even in our programming language. You can definitely use this as well. But the difference is this is often used for statisticians. So I'll just show this just to make it very, very clear. This is your R official website. It mainly suggests it's for statistical computing and graphics. So even in R, you do have certain packages to read input in different formats. You have certain packages to perform like machine learning. You have certain packages to visualize the data in maps and so many other things. You have all these things, but the main reason why R is used by a lot of developers is if they want to be statisticians, because you can work in depth within statistics. That's the main advantage for R. So if you want to go in depth within machine learning algorithms and you want to work on the statistics parts of it in great detail, this is probably the best one for you. But most of us in real life, we want to implement machine learning and use it to solve real world problems. So for that purpose, we often go for Python itself. So this is one more language that you have as an option. Followed by R, there's one more programming language again available called Julia. Julia is an amazingly fast programming language in terms of its execution. It executes at a very high speed, faster than probably Python itself. And that's one of the main reasons why people prefer Julia. It executes very quickly, and again, you can mainly use it for math and statistical functions. That is, if you want to go in depth and work through. So it's also easy to learn, but just remember, it doesn't have a lot of contributors. So it says Julia is open source with over 1,000 contributors. It doesn't have a lot of contributors who provide. You can perform some good data visualization with it, but of course, it doesn't have as many packages as you have within, let's say, Python in order to go ahead. But it still is a good option where you basically are using the scripting language, a very easy thing to perform. But then again, it doesn't have a lot of options. It doesn't have a lot of other things which you can do along with it. So that's one option that you have. Followed by this, there's one more programming language as an option that we need to know. That's called Lisp. If you remember, in our first or second session, we went through a particular app called Eliza. We looked at certain conversations that this artificial intelligence application did with humans. So this artificial intelligence application is able to communicate with humans, and people thought that it's a human typing, not an application typing. So this artificial intelligence application was also developed using Lisp. Lisp stands for list programming. In short, it stands for list programming. List programming is very easy to work on, especially with text data. So you can perform a lot of things. It's again very easy to work on with text data. You can create a lot of operations and perform this. Even though it's available, even though it has a small development community available with it, we still generally prefer Python for a reason, because you get more developer community to help you. You get a lot more packages to help you. There's a lot of developer communities who can help you debug programs along as well. So there are so many options, so many reasons why Python is often preferred. And with this option of Python, I will just explain to you why it matters which one to choose and why it doesn't. If you're working for a client, they want you to predict COVID cases. It doesn't matter which programming language you choose. All the client requires is you to predict accurately. All the client requires is you to predict accurately. That's all. They don't care about the fact whether you're predicting based on, let's say, for example, Python or Lisp or R or Java or anything. They don't care about it. The client only cares about you having an accurate prediction model. So that's what matters over there. Most companies want results, not a choice of programming languages. But in real world, there's a requirement for choice of programming languages for certain reasons. Why is that? Let's take a look. If you want to go into the field of data science, if you want to go into the field of machine learning, where you want to work on data science and machine learning in detail, Python is always preferred. This is where most of us go through. Python is always preferred here. So Python helps you with a lot of packages that I'll just show you in the next few minutes, which can help you out. If you want to be a statistician, then you can go for R. If you're working on a web application and you want to implement machine learning through web application, you need to use additional package using JavaScript, additional packages. If it's a Python full stack, you probably will use Python itself even here. So there are a lot of different scenarios, a lot of different examples that you can figure out. If you're an electronic engineer who wants to purely create it on a system where Python doesn't exist, R doesn't exist, JavaScript, Java, none of them exist, then you can even implement it on C++ as well. So all these options are there, but most of us generally end up going with Python unless we are hardcore statisticians with mathematics degrees and we want to go only within that and not learn much about data science. But this is the highest paid career in computer science field right now. This is the career which has the highest pay as a fresher as well. So that's why we prefer to choose this generally. So when we talk about this, how do I proceed with Python? Now comes a question. If I say Python is the best option to be learning data science, now you may ask a question. How do I proceed with Python then? You're going to need to learn a lot of things here. There's a particular package in Python called Numpy, which stands for numerical Python. This particular package is often used to perform mathematical operations. Now, if you remember, I had particularly stated that you need certain packages to perform efficiently. You need certain packages to be memory efficient, to be fast. So to make sure that all your machine learning operations are done quickly, so that you don't have to wait for days, or if your computer has a small amount of RAM, like 8 or 16 GB RAM as well, if you want your machine learning model to be able to be developed in such a computer, you need your programs to be memory efficient. You need them to be quick as well. So that is where we need a certain package called Numpy, which stands for numerical Python, which helps perform many numerical calculations in a very quick way and a very efficient way. It's a well optimized code which can help you easily perform mathematical operations. Since all your machine learning operations are based on math, statistics and everything, this package becomes highly useful. Apart from this, there's one more package that we need to know about. That is pandas. Now, the moment I say Python and pandas, don't start to think that it's all animals. So it's nothing related to animals. Pandas stands for panel data. That is what it stands for. So panel data, as in other words, your tabular data in short. So any tabular data that you're reading, whether you're reading it from Excel file, whether you're reading tabular data from, let's say something like anything else, let's say database file, let's say PDF file, whatever it could be. For all of these, we generally end up using pandas itself. So pandas is very highly useful if you want to read data in a certain way. If you want to read data from Excel files, if you want to read data in all of these database formats and everything, this is a very hugely useful package. Again, for every data science project, we're going to use all of these together. That's one thing we need to know and note. So here you can say pandas is used initially to read your Excel database, all these files, whatever you have. To read them, we use pandas. And when we read them using pandas, we need to perform mathematical operations for which we use Numpy. After we do this, how can I implement machine learning algorithms, you may ask? Like, where do I implement machine learning algorithms from? But before explaining that, let me explain to you about visualization. To visualize means whatever data you have to put it in graphical way. You have to put it in various graphical ways. To put your data in various graphical ways, we use matplotlib. Take this simple scenario. I'll just show you one small example of how matplotlib is hugely useful. Here, you can see a lot of different figures. I think they're unable to be rendered here, unfortunately, for some reason. That's completely all right. If they're unable to be rendered, I'll just show you in the same website as it is. So here you can see I'm able to render them. You can perform many kind of graphical representations. You want to figure out what is the heat levels, temperature, so on. All of these, whether it is world temperatures, whether it's a different kind of graph, whether it's a different kind of graph, line graph, or let's say something like stock market or something like CO2 emissions or anything, whatever graph you want to do, whatever graphs you literally want to perform, you can always use matplotlib. You can see that there are tens and tens of different graphical representations you can do. These are very useful to show the result in a graphical way to the user. Another way to do that is also using one more package called Seaborn. I think the website is not open. Let me just seaborn.pydata.org. Let me just open this website so I can show the same to you. You can see here, even using Seaborn, you can perform a lot of these operations directly using visualization. You can perform a lot of visualizations using Seaborn directly, which will make it very easy. So I'm just going to show you the gallery of what kind of different graphical representation you can make. So to show machine learning data to a client, especially when you have GBs and GBs of data, which you can not literally explain to the client by showing the text, it's often a better choice to explain it visually so that they can understand and they can make business decisions from these. That's why matplotlib and Seaborn are considered to be hugely powerful packages to visualize the data, and you can show these visualizations to the clients whenever and wherever required. So these are the advantages that you can have when it comes down to visualization in Python. You don't have just one package, you have multiple packages for all of these. And finally, let's go ahead to for visualization. We got to know we can use matplotlib as well as Seaborn. Now, along with matplotlib as well as Seaborn, if you want to implement machine learning algorithms, so you can create them. If you want to implement machine learning algorithms, so you can create your own model for any data. For that also, you need certain packages as well. So that is where the particular package called scikit-learn comes into picture. It's a hugely powerful package to perform machine learning. Any machine learning you want to perform, whether it is classification, regression, clustering, or model selection, any pre-processing operation, whatever you want to perform, everything can be performed using scikit-learn. So in short, it's an amazing set of tools which again are built on what we have just learned. Numpy, matplotlib, all of these are already existing within scikit-learn, so you can use them simultaneously. So scikit-learn is often used to create your own machine learning models, like predictive models or diagnostic models or whatever it could be. If you want to predict something like stock prices, if you want to predict something like image recognition or spam detection or customer segmentation or grouping of customers, whatever it is that you want to do, you can perform all these operations with scikit-learn directly, because they have all these algorithm implementations available directly within their own packages. So that's the major advantage that you need to know, and that's the major thing that we need to identify in order to work on this. So if you want to implement machine learning algorithms for your own packages, for your own creation of any prediction or anything, what you need to use is scikit-learn. Now, that's not all. Scikit-learn doesn't offer everything, unfortunately. As we learned, we have deep learning also, right? So deep learning is not offered by scikit-learn by itself. If you want to go perform deep learning, if you want to create all these artificial neural network algorithms and everything, you need to use something called TensorFlow. TensorFlow is currently maintained and identified by a lot of companies. Google is also one of them. And here you can create your neural networks using TensorFlow. We have seen in one of our last sessions what is neural networks, how to work with them. So TensorFlow can be used. TensorFlow has a many options within it. There's TensorFlow Lite for mobiles. There's TensorFlow for JavaScript also, for Python also, for all of these. So for our purpose, if you want to perform anything based on, let's say, deep learning, you need to use TensorFlow. But there's one little problem. For many new coders, TensorFlow often becomes difficult. If TensorFlow often becomes difficult, what else can we choose? Because TensorFlow is the only thing that you can use. If TensorFlow becomes difficult, there's another way you can do it, that is using keras. Keras is another package. I know you may be confused, like sir's pointing out too many things. Don't worry, I'll make it all easy by the end of this session. So keras is something else which is basically an API. So keras will create, is just built on top of TensorFlow. So anyway, all neural networks are created using TensorFlow itself. Keras is just one more layer on top of TensorFlow, which makes it easy for you to develop. It just makes it easy for you to write the code, because TensorFlow is slightly much more difficult. So all keras does is makes it just that much easier. So that's basically how we get to know. I have one question: how to know when to use deep learning or machine learning algorithms? It all depends on the data you have. For some particular scenario, for some particular examples, for some particular real world scenarios, TensorFlow may be way too complicated. You may want to use a simple model. When I say simple model, make no mistake, machine learning models are not so simple. They are very complicated too. But in machine learning models, there are certain complicated algorithms. If you want to, however, make sure that when you have lesser amount of data and you want to perform more operations, you generally go for TensorFlow. Nowadays, we use this more than ever because we call it state of the art machine learning. That is, we call it the latest and greatest things in machine learning. So we are starting to use this over machine learning more and more, but there's still a lot of scenarios where simple machine learning algorithms and complex machine learning algorithms which don't require neural networks are also used, because neural networks take more time, more complications, more computations, because they take a lot of energy and power. So a lot of cases you may not require them at all. So there's a lot of different scenarios that we may need to know. So in order to implement all these slightly complicated code in TensorFlow, you can always go ahead and use keras. Keras is just a layer on top of TensorFlow which minimizes number of user actions, which just helps you create code that much quicker. So if you're learning TensorFlow, you may as well learn keras as well. And once this is done, the next big thing in machine learning, the latest and greatest thing, are transformers, which transform model of one domain to a different domain, which we also called as transfer learning. So transfer learning, if you really want to implement it, I'm going to give you this little icon. It's a hugging face. So if you want to implement transformers, you need to learn hugging face libraries. So there's something particularly called hugging face libraries which you can learn. So it's an open community where a lot of people create their own different transfer learning models. Like if you see here, there's GPT model, there's some Roberta model, there's so many different models that exist. All of these are transfer learning models. If you want to use any of these, as we learned, there's BERT, Roberta, sentence transformer, there's in Roboto different cases, different parts, there's GPT, there's so many different transfer learning models, and even Google's own BERT is also there. So all of these are here, all of their implementations are also here. So if you want to work on transfer learning, for that you need Hugging Face libraries. So in short, if you want to be good at machine learning, you need to learn pandas, you need to learn Numpy, you need to learn scikit-learn, you need to learn matplotlib and or seaborn, you need to learn tensorflow, keras and Hugging Face, and you need to practice them with many real world problems to see and understand which is useful where and which is not useful where. And it's not just about the programming languages, you need to also learn statistics that belong with it. How do we proceed with statistics and everything? We'll see that in the next session. Let's not worry about that for today. For now, all I want to mainly focus on is the programming language part of you. What is it that you want to learn? So just remember, statistics and programming language both are equally important for a machine learning engineer. So these are all that you need to learn to become an expert in ML. If you're looking to find a shortcut way to learn all of this, we have our special course, that is our internship course on machine learning, where we will be teaching all that I just described to you and much more as well. There is no other course, as far as we are concerned, throughout, which offers all of these with live interactions and one-to-one mentoring and doubt clearing sessions the way we provide anywhere else for the affordable cost as well. So if you want to make your career in the highest paid industry in the best and easiest way possible, just go through the details of this video, just go through the info and description of this video. You should be able to access the link to get to know what is our internship about and how to access it. So with this, I hope by end of today, everyone has a real good idea of how exactly machine learning requires programming languages, which is to be preferred if we are learning, what and all are we supposed to learn. So with this, we'll end our session here today. So thanks a lot for joining this mini series, this episode of the mini series. In the next session, we're going to take a look at statistics a little in detail. Why is it important? Is it really important? And how do we work around it? So again, thanks a lot for joining. We'll catch up in the next session. Until then, take care and have a good time. So I have one question. Will you be taking internship classes for us? Absolutely, yes. I'll be taking all these internship classes for you guys. Yes. From scratch, from the basics of Python until you're an expert in transfer learning. Everything we're going to be teaching you in detail. So I'll be taking up the sessions. Yes.